Hey there everyone. So we can also use Venn diagrams to illustrate regions such as union or intersections of sets. So the shaded regions of a Venn diagram can be used to verify sets identities. So let's see. Again, what's a Venn diagram? Well, we draw a rectangle. That's our universal set. So everything that we're taking into consideration is going to be inside of this, right? And well, inside we may have set A and set B. Right? Those could be our, let's just assume we've got two sets inside. Right? So if, now let's make a copy of this. So what if I want to represent just set A? I would shade set A, right? That's it. So shade set A. That's it. I could do the same thing for set B, right? I've shaded everything which is inside of set B. Okay? Now what about the union between A and B? So union, it's OR. So I've got elements which are in either of those sets. So it's A, it's basically everything which is in A and, right, everything which is in B here. So I'm taking into consideration what's in both sets, that's union, right? If this, I don't know, if this is a person and this is another person, they get married, and what they have now is what both of them had before. What if I want to do an intersection? Well, the intersection is what both of them have in common. That's the end, right? What does A have and B also has? Right here, that's what we call OR, because if either one of them has this element, it will also be in the union, right? So that's OR. If it's in A or in B, it will be in the union. And this here, it's AND. So it means it will only be in this set if it's in both of them. If it's in A and in B. If it's only in A, it will not be in this intersection. If it's only in set B, it will also not be in this intersection. It has to be in both sets at the same time. Now what about our complementary sets? So this means not A. So A, as we have seen here in the first diagram, it's shaded, right? A. Not A, you basically revert this. You make the reverse. So everything which is outside of A would be shaded, right? Everything which is outside of A. And that's it. That would be not A. There you go. Now, just by observing those sets, we can get to some identities. So, for example, what would be the union of set A and its complementary? So it's complement. So I've got not A here, so it's the complement of A, and I've got A. So if I add what's shaded in both of the graphs, I'll get my universal set. I'll get everything. So if I add any set with its complement, I should get the universal set. Now likewise, what would be the intersection between A and its complement? Now intersection is what both of them have in common, right? So that's AND. What does A have and not A also has? Nothing. So that's empty. So on this last graph here, on this last diagram, let's do complement of B. So it's everything which is outside of B. Right? So what would be not A union not B? So complement of A union complement of B. So same sets here, A, B, union. Now, not A, everything outside of A, and not B, everything outside of B. So it's going to be everything but the intersection. This is union, right? So we're going to add them, right? So if you shade everything which is shaded in not A, and you shade everything which is shaded in not B, what you have here, that's the intersection. So A, not A, union, not B, is A intersection B. Not, right? Because this is not in there. So that's exactly the opposite. If I do the complement of A intersection B, I would get exactly what's shown here, right? So that's why we need the complement here. Now we could also draw another diagram. A, B, U. And now let's do not A intersection with not B. So not A is everything outside of A, and not B is everything outside of B. So what do they have in common? Everything outside in either. Sorry, everything outside in both of them, right, at the same time. So that's what we would get. Now if you compare this with the union, what is it? That's the opposite, right? So we get another identity, which is A union B is not A, not B, and not that. Or you could have the not here, right? So those are some identities that we're going to be using in our mathematics course throughout the IGCSE. So let's take a look at some examples now. So on a separate Venn diagrams, shade the region representing. This is just like the questions that you would find on the IGCSE. Now in A or in B, but not in both. So in A or in B, but not in both. Now what would be in A? So let's draw those diagrams. So let's first draw them separately. So in A, now, so here that's A, or in B. So in A or in B. So or would be the union, right? So I'm talking about A or B. That would be A or B. Right? However, not in both. So I'm taking away the intersection. So our answer then, you would shade this piece and you would shade this piece here. In the textbook, it would look like this. So this is our answer to letter A. What about letter B now? It's not A, so complement of A, intersection with B. So it's AND. So not A, that's everything outside of A. So if this is A, right, you would simply shade everything outside. So that's not A. Intersection, so what does it have in common with B? So if you look at B, B is here. So the part which they actually have in common, right, would be, let's put a different color here, right, because this is B. Now the only part which is in both is this here. Looks like a moon, right? So that would be the answer. So this is the textbook better drawn represented version. Alright? Now basically what you have to look for is where does not A overlap B, or vice versa. Where does B overlap not A? Alright, so now that we know everything that we should know regarding Venn diagrams, let's work out some problems. So, this first one, the Venn diagram alongside illustrates the number of people in the sporting club who play tennis and hockey. So we've got here a set T, and we've got set H, right? Tennis and hockey. So if we interpret this data, you can already see that, well, there are a few people who do only tennis, 15. There's 26 people who do hockey, who play hockey. There's 27 people who do both, who play both. And 7 people who play nothing. So, letter A. Determine the number of people in the club. So, number of people in the club, well, I've got 15 plus 27 plus 26 plus 7. So 15 plus 27 plus 26 plus 7, which would be 75. And there you go, just add up those numbers. A huge difference here is that those numbers here, they are not actual numbers, right? In the past, we had sets, and we had like, oh, even numbers and odd numbers, prime numbers, right? We had those things. Those were actually, they were actual numbers, right? In this case now, those represent people. So here, this 15, it actually means, I don't know, Mike, Charlie, right? I don't know, Daniel, whatever. 15 people who play tennis. It's not the number 15. Right? That's a common misconception. Now letter B, number of people who play hockey. Well, 26 people play only hockey, but 27 people play hockey as well as tennis. So people who play hockey is actually 26 plus 27, because those 27 people, even though they play tennis as well, they play hockey. So if I'm asking you how many people play hockey, well, it's the 26 who only play hockey plus 27 people who play both hockey and tennis. So 53, right? Now, let us see, who play both sports? That's easy, that's the intersection. That's T intersection with H, right? That's 27. Letter D, right? 27, because that's the intersection here. How many people play both sports? Now letter D, how many people play neither? So they don't play any sport. So it's basically what's outside of any of those sets. So it's 7, right? In this case, it's A union B would be people who play anything. So it's not that. It's the complement of that, which is 7. Now letter E. How many people play at least one sport? So at least means it may play one sport or it may play 2 sports. So that's what it at least means. So it's basically everyone who's inside of the union. It's inside of either of those sets. So it's or, isn't it? It's tennis or hockey. So here would be 15 plus 27 plus 26, which is 68. Fair enough, isn't it? So another example now. In a class of 24 boys, 16 play football and 11 play baseball. If 2 play neither game, how many play both games? So here, 24 is actually the number of elements in my universal set, right? That's basically the total. If we add, so we're going to have here a Venn diagram, right? Let me just draw this larger. Okay, better now. So this is my, let's call this F, since it's football, and B for baseball. So I know that 16 people play football. That's not only this part. This is a common mistake. Students they come here, they write 16 because it's football and 11 baseball. That's wrong, because the 16 who play football, some of them might play baseball as well. So that's not right. So let's call X the number of people. So let X be the number of people who play both games. Okay? So let X be the number of people because that's what we don't know, isn't it? We know how many people we have, we know how many play football, how many play baseball, and how many play neither. So if X is the number of people who play both games, this intersection is X. The number of football people who play only football is 16 minus whatever, right? How many people play both. For example, if 2 people play football and basketball, and 16 play football, only 14 would play only football. Well, in baseball, it's 11 minus X. It's the same principle. If X people play football and baseball, the people who play only baseball, it's going to be 11 minus X. Right? And here outside is 2. We know that 2 people are outside. Now here, since those are numbers, it's common to put some brackets outside just to show that those are numbers. They represent numbers. They represent people. They are not actual numbers. So when I say here 24 boys, I'm talking about the number of elements in that set. Alright? So, we know that the total number of people in the universal set is 24. So if I add this 16 minus X, this X, and this 11 minus X, and this 2, I should get 24. Right? So 24 is my total. So it should be 16 minus X plus X plus 11 minus X, right? And Y plus 2. So this is only football, right? It's only F. This is both sports. This is only baseball, and this is neither. Right? So let's work it out. We can cancel some things, right? So 16, now minus X with plus X, we're going to get rid of that, plus 11 plus 2 minus X, right? So we can rearrange a few things. So let's get X to that side, 24 to the other side. So X will be 16 plus 11 That's 27 plus 2, 29 minus 24. Therefore, x is 5. So the number of people who play both sports is 5. So we could actually just redraw our Venn diagram. This is F, this is B. Now there's 2 people outside who play nothing. 16 minus x is going to be 11 people who play football, 5 people who play both, and baseball is 11 minus x, therefore it's 6. Now if we add those up, 11 plus 5, that's 16, plus 6, 22, plus 2, 24. So it works, it matches. Now that's the last example of today, and a slightly more difficult one, but you'll see that if you have understood everything so far, and if you remember your algebra, you should be able to deal with those problems strike on. Now, let's read it. So, in a senior class, all 29 students take one or more of biology, chemistry, and physics. The headmaster is informed that 15 take biology, 15 take chemistry, and 18 take physics. Yay, physics! Now, 10 take biology and chemistry, so both at the same time, okay, and 5 take chemistry and physics, and 7 take biology and physics. So here, those "and," they mean intersections. This would be B intersection with C, this would be C intersection with B. I'm calling obviously physics as set P, chemistry as set C, and biology as set B. Right, so those "and," they would be our intersections. Now, how many students take all 3 subjects? So the first thing that we would have to do is draw a Venn diagram. So, in this case, we have 3 sets. So it's going to be a bit different. Perhaps at first it might look a bit scary, but you shouldn't be scared. It's fairly simple. Now, let's see what we know. So in a senior class, all 29 students, so we know that the total is 29. Now 15 take biology, 15 take chemistry, and 18 take physics. So let's call this biology, chemistry, and physics. So we know that 15 is the total number of students who take biology. So this whole thing should be 15. Chemistry, same thing. This whole thing should be 15. And 18, this whole thing should be 18. Now let's do something similar to the previous example. So let x be the number of students taking all 3 subjects. Alright? So that's basically this in between here. The number of students who take all of those. Right? Now, if you observe here this portion, right, this slice, take a look. This is the intersection of P and C. So this intersection is the number of students who take both physics and chemistry. So physics and chemistry, it's 5. So if x do all of them, this would be 5 minus x. Right? Now we can do the same thing for biology and chemistry. Biology and chemistry, 10 students take both. So if x takes all 3, 10 minus x. Here, how many take biology and physics? Biology and physics, 7. So if it's x here, all 3, this is 7 minus x. For example, if x is 2, this would be 8, and then 8 plus 2 is 10. This would be 3, and 3 plus 2 would be 5. And this would be 5. 5 plus 2 is 7. Okay? Now we go another step. Now, if we're observing Set B here, people who take biology, the total number of students should be 15, right? So, 15 is... Now, if I take out this part, and this part, I would find what's only in B. People who do only biology. So the total is 15. So if I take 10 minus x, and then I also take away x, and I also take away 7 minus x, I should have how many students do only biology. So this would be 15 minus 10 plus x minus x minus 7 plus x. So we can cross out some of those x's. 15 minus 10, sorry. So that's x minus 2. So here, x minus 2. Now, if we do the same thing for chemistry, we'll have 15 students take chemistry, right? So people who do only chemistry, we're going to do negative 10 minus x, similar to what we did before, minus x minus 5 minus x, right? And then if we work this out, we should find x, x, right? Because we're going to cross 10, 5, and 15. So this is simply x. Now for physics, if we do exactly the same thing, we would have, in this case, 18 minus 10 minus x minus 5 minus, sorry, 7. And then we would get x plus 6. Now, we know that students take one or more of those subjects, so there's no one outside of those sets. And we know that the total number of students is 29. Therefore, 29 should be equal to the sum of all of those things. So let's make some room here. Alright, so 29, which is the total number of students, should be equal to, and let's just add all of those things. So x minus 2 plus x minus 10 minus x plus 7 minus x plus x plus 5 minus x plus x plus 6. Okay, just make sure that you've added each one of them once. 10 minus x, x, 7 minus x, x, 5 minus x, x plus 6. So if you solve this, you would find simply, this is basic algebra, right? X is 3. So the number of students who take all 3 subjects is 3. And there you go.